Good morning, everybody. This is Brian Selby. I'm your host of Code and Coffee. Thank you for tuning in today to the live broadcast. If you're watching this via recording, welcome. You're welcome to add comments, questions at the bottom. Our live broadcasts are done on Friday mornings. We try to do once a month as our schedule allows, but you're welcome to type in the chat window. We're doing a little I wouldn't say competition, but we're doing a giveaway here. I'm going to show you in a minute image or a picture of our Code and Coffee mugs. So we're encouraging people to type in chat questions. I try to keep a good handle on the questions that are coming in. So the most prolific chatter or the best questions or things like that, we'll decide on somebody who will receive, or maybe more than one person receive one of these Code and Coffee mugs. So I wanted to thank our sponsors. These episodes are brought to you by EnergyCodeAce.com, and that is supported through ratepayer funds through the investor-owned utilities, through the auspices of the CPUC. So thank you, utilities, specifically PG&E, my program manager, Joe Marver, who is taking the risk in allowing me to do these things. So it's awesome. Let's get our introduction here. Let's introduce our project. So today, this is episode 1 of the residential modeling accessory dwelling units. So we're going to be modeling a newly conditioned detached accessory dwelling unit. I'm going to introduce the project here in just a minute, but if you look at our episode here, we're going to be reviewing the plans. We're going to be performing takeoffs for this newly conditioned ADU, modeling it in EnergyPro. So someday I might switch over and do modeling in CBEC Res too. That way we kind of trade off a little bit. But right now we're going to be modeling in EnergyPro. We're going to consider recommendations for compliance with the standards. So in addition to that, we've got some new information from the Energy Commission I wanted to highlight here. So some of the software we're going to be using, I use Bluebeam software for viewing, measuring, marking up PDF documents. So that's a paid piece of software that I use. I like it. I'm not endorsed by Bluebeam at all. So that's on your own. You can use whatever you like. I'm neither endorsed or paid by EnergyPro to use their software. I just prefer it. I also like CBEC Res too. So, all right. Without further ado, I'm not going to get into about me. We got a lot to do here. I do want to highlight a few things. So, those of you who have not seen the Code and Coffee mugs, that's the Energy Code Ace side. Flip it around, and you get the Code and Coffee mug. So, again, just we encourage you to type in the chat window. I see the chat just blowing up there. A couple of other items I wanted to highlight here. If you haven't done so already, go to the Energy Code Ace site, and you can download PDF copies of our application guides. Here's our residential HVAC and plumbing application guide. There are people on this call that help produce that. The residential envelope and solar ready application guide. Myself, Rosemary Halley from Gable Associates worked on this, as well as people from Noresco. Our friends over at the CLTC developed the residential lighting application guide. So these are wonderful guides to help you understand, apply the energy code. Awesome stuff. Our very own Gina Rada developed this, the non-residential lighting wheel. Awesome wheel. I'm going to be doing a video here shortly, maybe even later today, that explains how to use this. So if you haven't got one of these, if you see us at one of the functions we're a vendor at, ask for a lighting wheel. Otherwise, you can go online and purchase those. So, all right, let's dive into our project. So let's not do that screen. Let's introduce you to our project. So right now we have this is a real project. One of my clients, Mark Rylovich from Rylovision, sent me this project here. Anyways, it's converting, you see this existing garage here. It's a small garage that I believe was converted, and this is a code compliance issue. So they're going to be bringing this up to code and making it comply with the current standards. So very small ADU. It's an existing structure, and we're going to newly condition the space. So I wanted to bring to your attention some of the new information we've received from the Energy Commission. I'm going to switch screens here and highlight the most recent blueprint. This is issue 122, January-March 2018. You can go to the Energy Commission website and download this. Anyways, it's highlighting accessory dwelling units. So if you read through this, you'll see that a newly conditioned ADU, whether it's attached or detached, is considered an addition. It's not considered newly constructed. And if you see here what I've highlighted, this means that for compliance with Energy Code, attached ADUs as well as converted existing structures are considered additions. That has a huge impact on our compliance approach here. So if we look down, if you look through the blueprint here, it gives you some examples of what is an addition ADU, what is not considered an addition. If it's newly constructed, detached, that's new construction. So a couple of things to consider here, and we'll talk about the pros and cons of this, but if it's an addition, the Energy Commission says that, look, all the walls of this addition are treated as wall extensions. If you're familiar with section 120.2A, 1AI, and BII, this says that wall extensions can use the existing wall thickness. So if you have a 2x4 wall, you're only required to put R15 in that wall. And if it's a 2x6 wall, R19 insulation in that wall. Now, that covers you for the prescriptive approach, and that may be a viable approach for this ADU. Today, we're going to be modeling it, and we have some new information. This is the CBEC Res FAQ. This was posted April 10th, so 10 days ago. If you haven't downloaded this, you can go to the CBEC Res website, download the most recent FAQ, and it has some clarifications. So if you scroll down, so you can see updated April 10th here. I'm just going straight to the title here. So a recent blueprint, that's the one we just looked at, issue 122, says that when an existing attached or detached space is converted to an accessory dwelling unit, all of the existing walls can be considered wall extensions. Meaning that, here's our meeting the exception here, R15 and a 2x4 wall, R19 and a 2x6 wall, and no continuous insulation. So the Energy Commission has issued the workaround on this, saying that, look, if you have this situation, we know that the performance software cannot handle wall extensions yet. So in the interim, they've offered this solution. So model the wall based on the prescriptive requirement for your climate zone. So if you're in any of the climate zones except 6 and 7, you've got to meet that 0.051 U factor. And here's an example of a wall. This is the default wall for that 0.051 U factor. And as well as if you're in climate zone 6 and 7, the 0.065 U factor. So the question here, let's see, starting at a question about garage doors. Let's see it here. Oh, what if the question is, what if one of the doors is a garage door? Garage doors are not going to meet the requirements here. I see that down there. You'll see here in a second on our ADU unit that garage door was removed and infilled with a stud wall. So yeah, if it's a garage door, your typical metal doors is not going to meet the infiltration requirements nor the U factor requirements. So All right, back to the FAQ here. So this is an allowable approach. So it may not be the most ideal approach. You may have some pushback from the building department. They may say, look, you know, explain to us how you did this. You modeled it with continuous insulation, but now you're saying it's not required. So the Energy Commission's given us some clarification on that, and I'm going to go over some of the wording that I used for this particular project to explain this away. So got a little bit more in detail than their comment of identifying you know, the blueprint number and wall extensions and stuff like that. So all right, enough of that. Hopefully I'll post the links to these documents in the descriptions after. So let's get on to it. Yeah, we had a question here. Building department wants to see the garage conversion as new space, though. If that's the case, and if the building department is saying, no, we're not going to accept this as an addition, then, you know, you could show them this information. That's great. If not, you could, you know, model it as a new structure. And it's not technically how you should do it, but if that satisfies the building department, just keep in mind, you're going to be held to a much higher standard if that's a new space, as well as meeting the indoor air quality requirements. So looks like another question here. So an existing detached garage conversion is now an addition. That is correct, according to the Energy Commission. That's if the detached garage is existing. In this case, it is. How do we model it as an E plus A plus A? The software won't run without interior surface connecting. Yes, there's clarification in the CBEC Res FAQ. They say use 1 square foot adjacent to a residential space. So yeah, we're going to get into other episodes that might clarify some of these other questions that you're having. So yeah, even though it's an addition, even though it's an existing space. Yeah, so download the blueprint, download that FAQ. I'm not going to get in too much more detail about addressing that because it's going to take away time from our episode. I'm going to dive into our doing our takeoffs here. So we got two approaches. We could use the addition prescriptive approach. So in this case, we would have to assess whether or not we're going to trigger HERS measures. And if we did the AD02, that's the form that has the non-HERS measure addition, may apply to this. So you got to figure out which is the best method for you. This episode, we're going to be doing a performance approach, and we're going to be using the Energy Commission's interim workaround for wall extension. So I'm going to show you how to do that. So it looks like Simic says, I have a new single-family residence plus an ADU. Should I model an ADU as an addition? No, if it's a newly constructed ADU, no, you can't. That needs to be modeled as a new building. This addition exception only applies to existing spaces. So you're converting an existing attached space, like a garage, or an existing detached space. Like in our situation, we have a garage that we're converting to accessory dwelling unit. So, and then Brian says, can you then use an existing water heater rather than add a new one? That if you're doing an addition, yes, and the water heater is being supplied by the existing house, you could say that that's existing. Probably not going to be my strategy, and most likely that ADU is probably going to have its own water heater, but that really comes down to the project scope. So, all right, let's dive in and do some takeoffs here. So this is a pretty small building here. I'm using Bluebeam. So first thing I want to do, I want to calibrate my my space here. So I've got a known dimension of 18 feet. I'm just going to calibrate my workspace so that all my dimensions are correct. Say that that's 18 feet. Good. I always like to check one of my dimensions just to make sure that I got it correct. So beauty about Bluebeam, it'll snap to endpoints. which is really helpful. So it scales 19 feet there on my side dimension, so I know I'm good. First thing I want to do is my area takeoff. So if you look at the scope of work here, it's a pretty small addition, slab on grade, attic roof, as simple as you can get here. So the plan says 382 square feet, and I could do this probably manually, but I'm just going to do an area check just to make sure that we're on the money. So stand by here as I work my way around the building. Just double click to finish that area, and I get 382 square feet. How about that? We're right on the money. Perimeter length for our slab, if we have 382 square feet, I'm just going to grab this linear perimeter dimension, just work my way around the building. I could also just add these together. 19 plus 5 is 24 feet in one direction. I got 18 in the other direction. Add those together, multiply times 2. I get 84 linear feet. All right, question in the chat. Does the new wall replacing the garage door require footings if the current foundation is otherwise sound? That's more of a structural question, Stephen. Probably have to ask an engineer on that. Really, if the header was spanning the garage door, it's only the dead load of the wall there. So I don't know. Probably a better question for an engineer on that one. So okay, let's do some wall takeoffs. Our orientation here, we've got a north arrow on this plan. I'm going to call the front, this left side here, where this door is going into the kitchen. That's going to be my building front. So I'm going to check on my angle. I'm going to snap to the endpoint of this, 2 endpoints of the true north, and then I'm going to hold the shift button down and drag the length out this way. So it's saying it's 133.5 degrees negative of north. So what I'm going to do is take 360 degrees, and I'm going to subtract 133 degrees, 130, what are we at? Yeah, I think I went 133 degrees. So that gives us a front orientation of 227 degrees. So if you're looking at my over the shoulder here, I just write down on my takeoff sheet. Now, you may enter this in Bluebeam. I like to use just a grid pad. It's really fast for me to write down my information. I keep my front in the same relative area as the plan is. So it's going to be on the left of my page. Then I'm just going to work my way around. Left is going to be clockwise. Back is going to be, again, around, and then right. So you can just add those. Those are all 90 degrees away from each other. So 227 degrees. Add 90 degrees to that. So our left side is going to be 317. Add 90 to that. It's going to be 47 degrees. And add 90 to that, 137 degrees. So that's our 4 orientations. Let's do our wall takeoffs. Our front wall is 24 feet. So we've got, sorry for the jumpy screen there. So our front wall is represented by this wall here and this little wall of the bathroom. So 24 feet. Let me go to my second plan here. We've got some more information. That was the demo plan. So our ceiling height is 8 feet. So I'm going to take that 24 times 8. If you do that a lot, you know that's 192 square feet. So it's the wall length times the wall height. I'm going to do my back wall, 18 feet times 8 gives me 144. My back and my right wall are the same as my front and left wall, 192, 144. Let me get back to Bluebeam. All right. So we've got our wall takeoffs. Let's do our windows. I like to start with the front wall, and I go from right to left. Always go clockwise. That just keeps it straight in my brain where I'm at. If I ever have to go back in and edit that model, I know exactly where I left off and which window I'm talking about. Fortunately, this is a pretty small model. So let's take a look at these windows. This is a 5030 window, so it's 15 square feet on our front wall. That's the only window there. Our rear wall here. Let me see. We got a question. Christian says, if ADUs are treated as additions, do the CRRC cool roofing requirements still apply then? If you were altering the roof and you were altering more than 50% of that roof, then you would be required if there was a cool roof requirement in your climate zone. So yeah, you would still be compared to that. So in the software, you'd have to tell it you're altering the roof more than 50%. So okay, back to our back wall. We've got a 2020 window there. It's pretty small wording, so we got 4 square feet of window there. A 3030 window here, 9 square feet there. Back to our back wall. There are no windows on this back wall here, so we can just put a big 0 there. And our right wall has a 3036. That's 10.5 square feet. As far as my accuracy goes, usually I'll go to the first decimal point. You're splitting hairs, you go 2 decimal points. I don't know, some people may want to go that far. I think the EnergyPro rounds off to the nearest single decimal point, so I usually keep it there. Okay, so we got our window takeoffs. We have a door here. I don't see an opening width here. You know, in lieu of this, I'll probably bring this up to the client and say, hey, how big a door is that? Let's just do a dimension here. Looks like a 2.8 door. So that's a 2.8, and if we go back to our original picture, we see that door is a metal door. For modeling purposes, I'm going to assume this is an insulated core metal door, but I don't know that. It might be something I could ask the client though. So, but I'm going to, for modeling purposes, we're going to call that an insulated door. So a 2868 door is going to be 17.8 square feet. Okay, so we've got our takeoff here. I'm going to switch to my over-the-shoulder look here. Very simple. That's my data collection. I've got what I need to input into EnergyPro so far, minus any other details that I might be looking at. So, all right, let's switch to EnergyPro. And I know in the past I've done the wizard. This time I'm just going to create this from scratch. Some people like to create things from scratch. Some people like to use the wizard. I'm not partial. Sometimes I do a little bit of both. So this is our building. I'm going to call this our sample ADU here. As far as my front orientation, I'm going to call that 227 degrees. I've done a little bit of background on this. This project is located in Oakland, California. There is natural gas available, so we're going to keep that there. It's like Cynthia says, isn't that a new roof then, not an existing roof? Not sure what you're referring to, Cynthia. Are you referring to Christian's comment? Or, yeah, you can give me clarification on that. That'd be good. So maybe I can answer that then. So I'm going to go down to Oakland. Don't do a lot of projects in Oakland. Not Oakdale. That's Climate Zone 12. So Oakland, Climate Zone 3. All right. So we got our basic information. We're going to leave the project details done. We're going to leave that empty for right now. Go over to our residential tab, see if we have anything here. We're not proposing any cooling ventilation. It's not prescriptively, well, let's talk about that in a little bit. So, good. So let's go ahead and jump in and add a water heater, add add an HVAC system. We're going to go in and define these here. So we'll call this DHW system. And sometimes EnergyPro lags when I type in stuff here. So I don't know if anybody else has that. Hot water system. Okay, we're going to hit our DHW tab. We've got some information on the plan about our hot water heater. Let's see. Let me go to our Bluebeam screen and zoom in. We've got a Ring tankless natural gas water heater, 9 gallons per minute, model number ECOH18. I went to AHRI and I downloaded looked up that project, or looked up that water heater, and I'm going to share that with you here in just a second. Let's see, Ream. And if I go back to my other screen, you'll be able to see that. So this is my HRI certificate. Couple things I'd like to point out here, that this particular model has a uniform energy factor, a UEF of 0.93. So want to make sure that we do that. I'm going to take and copy this model number. I'm going to enter it into my hot water heater. Questions. Cynthia says, oh, Diane says building type, addition or new. Yeah, we'll get back to that building type. Yes, we're speaking to the cool roof question. Let me see if that, if it's a new construction, it would be considered a new roof. If it's an existing structure, is it considered a new roof or an existing roof? In this case, being that it's an addition, probably consider it a new roof in that case. So in that case, the roofing prescriptively would be, if you had a cool roof requirement in your climate zone, prescriptively you're going to be compared to that in the standard design. So you might take a little bit of an energy penalty if you didn't do that. So, and another question, it would be so nice to get that much information on my plans. Yeah, sometimes you don't get all this information. You got to pull it from the customer to get that. So I'm going to copy my default gas tankless. I'm going to call this my Ream. Paste my model number. I didn't work. We'll just call this tankless. And I'm going to look at my HRI rating here. I need to blow this up so I can actually see it. So it's a gas fired. Just want to point out that there's this button here for UEF rated. So this one is UEF rated. Our volume in gallons, according to HRI, is 0. Our BTU input rating is 180,000 BTUs per hour. Our UEF is 0.93. Don't make the mistake of typing in 93, right? That means you're 100 times more efficient than 0.93. So I've seen that happen sometimes. And our first hour, their gallons per minute rating on this, I believe it was 9 gallons on this one. Okay, we're going to choose that water heater. We're going to leave our distribution standard on that. Let's get into our HVAC system. I'm going to change this to HVAC system. This is going to be new. It is a, I think I already saved this, but let's go back to our plan and take a look at what that is. Bluebeam. We're proposing to put in a wall furnace here, 25,000 BTU natural gas wall heater, Williams model 2509622A. Went and looked that one up on AHRI. Now, they may have some issues providing direct heat to both bedrooms here. Couple solutions to that. They could put some jumper ducts in there, but in this case, I'm going to model it the way the customer sent it to me, and if there were some issues, I'm going to bring it to the customer's attention here. So let's get up our cut sheet. So this is the manufacturer's cut sheet for that particular wall furnace. I went to AHRI and got the HRI certificate for that. That is this one right here. So I like to go by what HRI says than what the manufacturer says. So this is a wall furnace. So I'm going to come back to EnergyPro and let you see my inputs. So I'm going to copy this existing wall furnace, and I'm just going to label this wall furnace. This is a split DX system. It's a gas furnace. It's gravity wall type. Our input on this, our BTU input is 25,000 BTUs. Our efficiency, keep in mind, this is an AFUE of 67%. So that's input of 0.67. All right, nothing else. We don't have any cooling in this. My cooling is set to 0. That's going to tell the software that there's no cooling installed and document that. Okay, I'm going to go back here and go over what I forgot to do is say that this is an addition in our building type. So make sure that that's selected. It's going to ask me for what the existing area is. Now, you may have this information from the client. I went to Zillow. I typed in the project address and I went to Zillow and I found that information. And that information was existing house was 1,052 square feet. So that's just going to give it relative to the project that it's being added onto. And it was a 2-bedroom house. So, okay. Looks like we probably got some more questions. Yeah, Zillow is a lifesaver, right? When you're looking for existing information. So, love it. Okay, so we got our mechanical systems input. Let's start with some zones here. Undefined zone, this is our new zone. I'm just going to call this ADU. All right, that's our condition type. It's single family. Let's go through and make sure that our building story information is correct. Ceiling height is 8 feet. Elevation above grade 0.7. That's basically a slab saying it's 8 inches above grade. Floor to floor height is 9 feet. So anything, this floor to floor height has to be greater than the ceiling height. Window height is 6'7". I don't need a second floor on that. It's only a single story building. And let's just say okay. I always like to do my dwelling tab right now and define my number of bedrooms here. If we look at our plan, we'll go back to a Bluebeam screen. This particular plan is 2 bedrooms, right? So there's a 2-bedroom ADU. So I'm going to input that into EnergyPro. It defaults to 3 bedrooms. So just go back in and change that to 2. I like to turn the appliances off. There's no credit, no penalty for using appliances or not using appliances. In this case, whatever is input in the proposed design is equal to the standard design. There's no consequence. I just like to turn them off. So that's my preference. Your preference may be to turn them on. So that's just the way I do it. Okay, we got our zone done. Let's add a room. And our room is going to be our, I just say it's our ADU unit. So we're going to model the whole unit together. We know what our square footage is, right? 382 square feet. So it'd be interesting to know if people are modeling along with me as I go. That'd be kind of cool to see if somebody was doing that. So the challenge to the Gable office, somebody do that. That'd be kind of fun. All right, I'm going to enter my slab area, my roof area. I know I have 4 walls. I'm just building my tree here, right? I'm just entering this information. So now I need to go in and define all these areas. So my slab area is 382 square feet. We know it's new. The assembly is slab on grade. It's non-heated, so I'm good with the default value here. If I was going to do that, a heated slab, I would go in and say, hey, I would import a heated slab and use that. But right now, this is an unheated slab. No slab perimeter insulation. It's just a slab here. Okay, my exterior perimeter, that's the perimeter around my floor area, 382 square feet of area and 84 linear feet. I'm going to keep the default 20% exposed on this. We don't know what coverings they're going to be putting on it, so we're not going to make any claims there for thermal mass. Our roof area, again, is the same, 382 square feet. It's a new roof. Now, what are we doing here for roof attic? So we could look up and see what the prescriptive requirement is for climate zone 3. You know, I know the client. I've had conversations with the client. They're okay with putting our 38 attic insulation in here. They're not putting a high performance roof here. At this situation, we're only adding ceiling insulation, R38. Our framing is 2x4, 24 inches on center. We're good there. We're not putting in a radiant barrier. We're not putting in a cool roof at this point. We know that we may have some cool roof requirements, but we're not going to be doing that. Orientation is being relative to the front, 227 degrees. Also, our slope. This is important. If you don't put in a slope, the software says, look, if you're saying it's an attic space and there's 0 slope here, and if you had ducts in that space, then you wouldn't have enough room there. So what is our roof slope? Let me go back to Bluebeam. The only thing I have that shows kind of a roof slope is this front elevation. So I know this picture is a little skewed, but I can roughly guess. I'm guessing it's a 4 and 12, but it might be in 5 and 12. But you can come in here and grab your angle, right, and come in here and say, just as a gut check, it says it's 19 degrees. If it's at a skew, it's probably showing that it's a little bit steeper. So I would say, what is a 4 and 12? 18 point something, 18.6. So I'm going to say that that's a 4 and 12 roof. It would be upwards to 20, 20.2, 20.3 for a 5 and 12. So, Simic says, what is the roof orientation and is it always front? If you're doing an attic roof, yes, the orientation of that attic roof would be the front orientation. Now, if you're doing a cathedral roof, you would need, and if this particular roof over here was a rafter, you would need to model the area relative to this rafter in this slope in this orientation, and this rafter relative to the slope and orientation. So you'd break the two in half, the area in half, and model one facet one direction, one facet another at their respective roof pitch. So, but if it's a vented attic or an attic roof, then we're just saying that orientation is the front orientation at this point. So, okay, forgot to go in and do my distribution system for my HVAC. So in this case, it's new. My heating distribution is ductless, no fan. So let's see, nothing else on here. We have no HERS verifications. We're good. All right. Back to our areas. We've got our slab, we got our roof, we got our exterior wall. I'm going to start with my front wall. I always like to start with front first and go clockwise. I'm going to call this front wall. If we go back to our takeoff information, we know that that front area is 192 square feet. It's a new surface. our assembly type. Now, we got to refer back to our CBEC Res software. So we are in climate zone 3. So climate zones 1 through 5 and 8 through 16 have a 0.051 U factor. So the CBEC Res FAQ is saying we need to model that 0.051 U factor this way. R19, 5.5 inch cavity, 2x6, 16 inches on center with R5 sheathing, synthetic stucco. That's the default 0.051 U factor for that wall. So we need to model that. Right now, let's see, I got a bunch of stuff in my file here. So Brian says, are you saying that all cathedral roofs are supposed to be modeled separately based on orientation? Yes. So each facet, each individually facing cathedral roof needs to be modeled according to its slope or pitch and its relative orientation. So yeah, not just a single orientation. All right, so we're going to copy this wall here. We're going to call it our R19 plus R5 wall. And we're going to go in, yeah, how common are 2x6 walls in this? Actually, we're not going to model a 2x6 wall. Thank you, Sam, for bringing that to my attention. My project says here that existing walls and new walls are all 2x4. So what we need to model is a R15 wall, right? And if we go back to CBEC Res, the FAQ, let's see. Well, it's saying model the 051 is this one. We can model it as long as we get the 0.051 U factor. We're fine. I'm going to model it with the 2x4 wall, but yeah, let's keep it this. CBEC Res says model it this way, and then provide clarification to the plan checker, and we're going to do that in the remarks. So we're going to click on the Title 24 Performance. Right now we have the R19 5.5 inch cavity, 2x6, 16 inches on center. We're going to add the R5 continuous insulation to the outside. We're going to select the synthetic stucco. Okay, so that's going to give us our actual assembly here. We're going to say that the orientation is 227 degrees. The tilt is 90. Now, if you notice, an EnergyPro has this extension to an existing wall button. That's only for the prescriptive approach. So it's not going to do anything. If you have the prescriptive module from EnergyPro, it's going to identify that as a wall extension. In this case, oops, forgot to change that. That's actually an R19 wall. In this case, that is not functional right now for the performance approach. So let's add our windows to that front wall. We know we have a see, Simic says, I guess we need to update the new assembly reading. I'm not sure what that means, Simic, but yeah, if you can clarify that question. And then wouldn't this wall be existing? No, actually, since this is an addition, it's a new wall. It's not an existing wall. It just, the clarification from the Energy Commission says you can treat that as an existing wall and apply the wall extension exception. So, all right, good. So we got a wall 1. We've got our first window. We've got 15 square feet of window on the front wall. For right now, if you look at the prescriptive requirements for climate zone 3, the U factor is 0.32, but it doesn't have a solar heat gain coefficient requirement. In that case, the software defaults to a 0.50 solar heat gain coefficient. So in this case, if you use the 0.25, you're probably going to get a energy penalty for doing that. So just want to bring that to your attention. Let me see how for this, I'm going to model this as a 0.50 energy factor, and I'm going to change this residential prescriptive to a little more descriptive. U factor 0.32, SHGC 0.50. Now, I definitely want to communicate to the client that, hey, we've got a 0.32 U factor window, but the 0.50 SHGC on that on the shading coefficient. So that might be a more risky way to go. In this case, I want to make it clear to the client. But if they install the 0.25 or somewhere in that range solar heating coefficient, it's probably going to see an energy penalty in climate zone 3. So I'm just predicting that up front. But we're going to go this route here for now and show you what the results are on that. So you guys can decide on which strategy you're going to use with your client on window performance. But this is the one we're going to take for now. All right, so we're not going to model overhangs in this one. There's one of the episodes, episode 2, I believe, has how to model overhangs and side fins. So no other windows on the front, but we do have a door. Let's add that door. This door is 17.8 square feet. Looks like Bebo210 says, but the wall is already there. Won't you need to model it as existing? Yeah, I agree with your logic on that. It is already there. It's an existing unconditioned structure. We're converting it to a newly conditioned structure. Therefore, the wall is new. It's just we're taking this new clarification from the Energy Commission saying that this is an addition, and we can apply the wall extension exception to that. So I hope that makes sense. Yeah, the wall is existing, but we're not calculating it as if it were an existing wall. We're saying it's a new wall because it's relative to a newly conditioned space. So, all right, Simic says, I could comply with 1% using one of my existing models, but when I changed the exterior wall finish to synthetic stucco, then it dropped to 0.3. Any idea? Not sure, Simic. I'd have to take a look at that. You're probably, I don't know. I have to take a look at that. Maybe hit me up at AceTV at energycodeace.com email, and we can take care of that one offline. All right, back to our doors here. In Windows, we'll get that the question from Bebo210 in just a second here. Let me do my left wall. Again, I go clockwise. Starting with the front, my left wall is at the top of the screen. If you look at the plan, let me just minimize this plan. My left wall is up here, that 18-foot dimension. Okay, so always keep things relative to where I'm at. All right, my left wall is 144 square feet. It's a new wall. I need to select my assembly. This new R19 plus R5 wall. Orientation is 317 degrees. Tilt 90. I'm good there. Left wall has 2 windows. We're adding a new window. And if you're not familiar with EnergyPro, I just right-click on my wall and click the Add Window feature. Since I have 2 windows, I'm going to add 2 windows there. The first window is 4 square feet, and that's going to use this 0.32 U factor, 0.50 SHGC window. It's a new window. You could also model those as default values if you wanted. If you had no idea, you could go to table 110.6 A and B, which the software effectively does that if you choose the defaults there. You just need to configure it correctly. Window number 2 is 9 square feet. Same performance factors apply there. My left wall is good. My rear wall, let's enter those characteristics here. Rear, you might have different names for these surfaces. I like to just call them front, left, rear, and right. So it's 192 square feet. All right, let's take care of some chat questions here. Bebo210, but you would have to model the wall as it is unless you are changing the assembly. Okay, we're using the CBEC Res workaround in this case. We're not modeling the wall as existing. We're modeling the wall as new. We're modeling it with the prescriptive .051 characteristics. And we're going to explain to the building department the exception that we used. This is the risky part because it opens the door to a lot of confusion. And I agree 100%. We're just going to model it this way and try to address that and clarify that to our building department. I know personally, I'd probably take just a little bit different approach. So, but I know this is confusing. Bear with me. We'll have a solution at the end here. Okay. Chandra, I've noticed changing the wall finish now, changing compliance. Okay, so you notice a difference there. Maybe we'll have Lindsay put the email address in the text window there. And then Diane says, City of San Diego wants window sizes input. Yeah, some building departments want you to say what the window size is on the inputs. That's great. You can do that. Just enter in the window name, enter the size. So, okay. Let's get back to the rear wall. We're running a little bit behind on time here. I want to speed this up, so bear with me. I'll try to address your questions as I can here. Rear wall, I want to change the assembly to our prescriptive assembly. The orientation is 47 degrees, and we have no windows there. Our right wall is 144 square feet. It also has that prescriptive .051 default wall here. Orientation is 137 degrees. We do have one window in that wall. It's 10.5 square feet. So to Diane's point here, we could do a 3 by 3.5 if you wanted to add the window sizes into those, or if you had a note, a window schedule, tag or something like that. So keep in mind that CBEC Res is going to add a number to the end of this. It's going to say window 3 by 3.51 or window 1, 2, 3, 4. So just keep that in mind. So, okay, we've got our building. Let's just go back through and make sure that we have everything done correctly. We have a ADU. It's an addition. Okay, I'll take care of the chats here in a little bit. So keep chatting. I'll have to address these in just a few minutes. We'll probably have to wrap up with some answers to the chat window. So we've got an ADU facing 227 degrees north. The existing area that the existing house that we're adding onto theoretically is 1,052 square feet, 2-bedroom. It's in Oakland, California, climate zone 3, natural gas. Our DHW system is a gas tankless system. It has a 0.93 UEF, universal energy factor, 0 gallons, 180,000 BTUs input. Our HVAC system is a wall furnace, a gas wall furnace, 67 AFUE. Distribution is going to be ductless, no fan on that. Our zone, we've got a conditioned zone, single floor, 8-foot ceiling height, 2 bedrooms. I unchecked all the appliances, and our room is 382 square feet. So we entered our slab information, our roof information, all of our walls, windows, doors, ceiling, floors. So we hit calculate here, and for purposes, I've gone ahead and calculated this just for the sake of time, and we come up with a energy savings of 0.1%. Wow, just the skin of our teeth that we complied with. Now, we want to address this issue about informing the building department, right? We want to look at, adding some sort of remark here. So this is the remark I came up with. I like to highlight, hey, plans examiner, Please review the following note to clarify what is to be installed concerning wall insulation. So I've taken the Energy Commission's suggestion and then added to this. So I'm adding this note. This project consists of converting an existing detached garage into a newly conditioned ADU that was modeled as an addition. So I'm clarifying it right up front. Okay. All exterior walls were modeled with the prescriptive wall requirements for climate zone 3. That's the 0.051 U factor. Please note that no continuous insulation is required for the exterior walls, only R15 cavity insulation in a 2x4 wall or R19 cavity insulation in a 2x6 wall is required. See California Energy Commission Blueprint number 122 and CBEC Res FAQ April 10, 2018 for clarification. Then I've added these links to that. And I'll add this to the description of the YouTube episode here, so you guys can copy and paste that. So that's what I'm doing for that. Let's take a look at our results here from EnergyPro and just verify that these results are good to go. Let's scroll down here and get to our page 1. Oops, sorry about that jumping around. So just to make sure that we got this right, we're Climate Zone 3, Oakland, California, 382 square feet. It was modeled with a front orientation at 227 degrees. It's a single zone, natural gas is available. 2 bedrooms on the existing, 2 bedrooms on the addition, right? So that's calculating that correctly. Here's our proposed design, 47.343 thousand BTUs per square foot annually. Our compliance margin was 0.48, which has a 1% improvement. So it complied, right? We may want to make recommendations to the client to exceed that, or we may have to tweak a few things. The window assumption that we took may not be the right window assumption. So these are the types of communications that you definitely want to bring up with that client. Hey, let's talk about windows. Let's talk about wall construction. Let's talk about attic ceiling insulation. Are you replacing that roof? If so, can we take advantage of a cool roof? Things like that. Funny thing is, this particular project, because it's an addition, didn't have any HERS verifications. Therefore, we don't have a watermark saying that this needs to be registered. So in this situation, we could submit this without HERS provider registration. So no HERS features there. Conditioned floor area, 382 square feet. Take a look at our conditioned zone. We're good there. Ceiling height's 8 feet. We've got our prescriptive wall. That was what the Energy Commission instructed to input as the construction type. All of our orientations are correct. Our areas are correct. Let's look at our attic. We got a 4 and 12 pitch. We don't have a cool roof. We don't have a radiant barrier. We're good there. We've got 4 windows. We can verify these. Front wall is 15 square feet. Left wall is 4 square feet and 9 square feet. And then our right wall is 10.5 square feet with these performance characteristics here. And again, that 0.50 solar heat gain coefficient, make sure your client realizes that if you're in climate zone 1, 3, or 5, as they don't have a solar heat gain coefficient requirement here. These are our opaque surface constructions. We've got our attic roof. That's the roof portion of our attic. All right. We also have a ceiling below that. So we're not putting in the insulation at the roof framing. We're putting our insulation at the ceiling framing. So R38 at the ceiling. Actually, in my sample, I did model this as a 2x4 with R15 in that wall with the R3.8. So yeah, so here's it done 2 ways. Either way, as long as actually that came out 0.065, we're actually going to be better. So I apologize for that one. I should have caught that. We should have gotten 0.051 wall there. So, which is going to make our compliance margin a little bit better. Slab on grade, we're good. A DHW system, single water heater. It's a consumer instantaneous with a UEF factor of 0.93, 188,000 BTUs. Our heating system, gravity wall furnace with a 67 AFUE. Now, here's where my project notes came in. These are my remarks that I'm making. Hopefully this will be clarified. Now, I may want to also do a separate letter to the plans examiner and submit that along with my compliance documentation, just to clarify this exception that's going on. Now, I'm not sure if I'd take this route with my client, depending on the billing department, but if I called the billing department ahead of time, talk to the plans examiners, talk to the building official and say, look, hey, what do you guys feel about this approach? Do you have any heartburn over it? Do you need any more information? What can we do to make this happen in this situation? So otherwise, I'd probably go the prescriptive route, a prescriptive addition on this particular project, because other than maybe a radiant barrier or cool roof, we'll have to take a look at the prescriptive requirements. It wouldn't really impact the building as much as it would having to run this as a new structure. So, okay, that said, pretty much wraps up our episode. We're right about an hour here. Let me see if I can answer some of these questions here. Simic says, let me go over here and excuse me while I take a sip of my coffee here. It is Code and Coffee, by the way. All right. Some of the questions here. Simic says, please text your email address if possible. I think Lindsay did that. I would say use our AceTV at energycodeace.com. That also comes to me. Let's see, going back down, Cynthia says, wall finish change. You are changing the U factor when you change the wall finish. Absolutely, Cynthia, and thank you for that comment. We need to model the workaround as 0.051. Yeah, it needs to match that 0.051 U factor. That's the key part of using this workaround, is that wall needs to be a 0.051. Simic says, sorry, can we use wall surface type alter instead of new? You're not going to show an altered wall. That would be for an E plus A approach. So this is an addition. You're modeling it as an addition alone. Those surfaces, as far as for modeling purposes, are considered new. It's not an altered wall because we're not taking existing features and changing it. So model those as new walls. Okay, Mufid says, if not more efficient to have 0.25 SHGC. Well, Mufid, you got to look at this on a climate-specific issue. If you were in the Central Valley, climate zone 11, 12, 13, absolutely. The 0.25 SHGC is going to be better than the 0.50 value there. But because it's in climate zone 3, climate zone 1, 3, and 5 do not have an SHGC requirement, because what happens in those colder months, you want that heat-causing light to penetrate that window. Otherwise, if you filter it out, you're going to be turning on a furnace, turning on some heat, using more energy. You're kind of defeating the purpose. So hopefully, in this case, the 0.25 solar heat gain coefficient would result in a penalty in climate zones 1, 3, and 5. So Diane says, building department makes me remove that number that the software adds. Oh my gosh. That's a lot of work, Diane. I'm so sorry. Yeah, I can see where it can be confusing. I wish there was a way that was more of a user input. So maybe in the future. So Jared says, if there is a new ducted furnace, would HERS registration be required? Absolutely, Jared. If you put in a new furnace and there's ducts, if it's duct in the attic or in the conditioned space, absolutely that would trigger HERS verifications, and then you would have to register this project with a HERS provider. So Dan says you could add a couple of something at each wall. Oh, a couple of inputs or asterisks at each wall name to include a note at the end of the report. And that would be a good way to handle that, Diane. Some asterisks that would highlight, hey, look at the remarks, might bring that to attention. So Mike says, did I see the report shows 4 bedrooms? 4 bedrooms total, Mike. Our addition has 2 bedrooms, and our existing house has 2 bedrooms. So, good. All right. Well, that's it, man. I didn't realize this is going to take an hour to do this episode. So, I want to thank everybody. I know there are going to be lots more questions on this. This is relatively new. I'm planning on doing a series on ADUs. All right. Because this is such a hot topic, I think it's really important to really dive in deep on these. This is one of the 3 different scenarios, right? So this is an existing detached. We will have an existing attached, and we're going to have a newly constructed detached ADU. So hopefully work our way through these. Please, if you have questions, email me at acetv@energycodeace.com. You can find that in the description below. Please hit the like button. That just kind of gives us, some feedback from you. If you have any suggestions for improvements to the show, please feel free to email them or put them in the comments below. So I want to thank you, everybody, so much for your participation. What was our total viewer count today? Anybody take a look at that? Looks like we're up to like around 60 plus or so. That's awesome. So I want to thank you, everybody. Hope you have a wonderful day. And don't forget to hit that like and share button. And we'll see you on the next episode. Have a good day.